Hey, what's up y'all? This is Adam the Tutor coming at you with another derivative video, and this time we're doing a general power rule. So this is going to be the basically the derivation of the power rule. Alright, so, for any power of x, 2, 5, whatever, what have you, right? Okay, so first of all, we already have our definition for the derivative here. So let's go ahead and switch colors here, and let's go ahead and evaluate that. I just said go ahead twice, but that's okay. Alright, so d dx of x to the n, right? And then of course, I'll mention n is a member of the integers, right? Well, actually, it doesn't necessarily have to be that case. But, n is just, right now, it's just basically a number. It doesn't have to be an integer. It could be a fraction, too. So, alright, so anyway. So we have the derivative of x to the n is equal to x plus delta x to the n minus x to the n, right? Oh, and then I have a limit here. Let me just squeeze that in here. Limit as delta x approaches 0. And then we're going to have delta x. So basically how this is going to go is we're just going to basically write out the first few terms, right? So in this first one, I know my first term is going to be x to the n, right? And then my second one, I'm going to have, let's see here, when n, okay, so I need k, okay, so k is equal to 0 here, so now I'm adding in the first term, right? So then this would be n choose 1, and then I would have x to the n minus 1, and then times delta x, and then I would have plus n choose 2, x to the n minus 2, and then I would have delta x squared, and basically so on and so forth, right? And then of course at the end here, I have minus x to the n. Alright? And then this is all over delta x, and of course again, I keep forgetting my limit, don't know why. A little bit early this morning, probably why. Early start for me. But you don't want to forget this limit right here, that is important. Okay? So now, first thing you'll notice here, and I'll just go ahead, I need to start using more colors. Oh, well, that's not using a different color. There we go. So first thing you'll notice is that this guy and this guy are going to cancel out, right? So then what I have is well, and let's also go ahead and divide by delta x, right? So I'll have n choose 1, x to the n minus 1, delta x divides out, plus n choose 2, and then we'll have x to the n minus 2, delta x, and we can include the other term, which would be, just so you can see the pattern, n choose 3, x to the n minus 3, and this would be a delta x cubed, but since we divide by delta x, it's delta x squared. And of course, limit as delta x approaches 0. Right? So basically, the thing to notice here, right, is that this term has a delta x, this term has a delta x. And basically what's happening is the delta x is the power on that is going to get higher. So here it's 1, here it's 2, and the next term it would be 3, and 4, and it would just keep going and going up until you reached n. So basically, you know, these guys all go to 0. And you're only left with this guy, right? So then that means that the derivative with respect to x of x to the n is equal to, okay, well, it's equal to this, but we can simplify n choose 1, right? That's actually just n, right? So it would be n x to the n minus 1. And that is our power rule right there, right? So basically what happens if you have this x to the n right here, if you have this x to the n right here, basically the exponent comes down, becomes the coefficient here, and then you decrement the exponent by 1, right? So that's basically how you do it. And this works for, you know, basically any real number, you know, if this is 5 or 1/2 or -3/7, you know, it doesn't matter. It will work for that, right? It's just here, you know, here you're, you know, there's no requirement on n, right? The integer requirement here is on k, but you know that ultimately doesn't matter because ultimately it's just the first term that ends up surviving anyway. So there's no requirement on n to be an integer. It's kind of a little bit early, so that's kind of why I was saying that. But you know, it's all good now, and that is the power, or well, that is the derivation of the power rule, right? And I'm pretty sure that's going to do it for this video. If you have a comment or question, drop it in the comments section below, and I'll gladly address that. And as always, thank you for watching, and I will see you in the next video.